Assalamu alaikum, ma'am. I'm Zakari Hussain Faisal, ID 171159556. My presentation topic is rendering. Rendering is also known as image synthesis. Rendering or image synthesis is the process of generating a photorealistic or non-realistic image from a 2D or 3D model, and it's actually done by some computer program. The resulting image is referred to as the render. This means whatever we are doing in our rendering, after the output file or the output graphics file is actually called as render. Multiple models can be defined in a scene file containing objects in a strictly defined language or data structure. The scene file contains geometry, viewpoint, texture, lighting, and shading information describing the virtual scene. Actually, first of all we have a virtual scene, and we need to apply some geometry, viewpoint, texting, or lighting or shading information through our computer program on the virtual scene, and after that we will get our rendered image or rendered graphics. That the data containing in scene file is then passed to the rendering program, what already I have said, to be processed and output to a digital image or raster graphics image file. The term rendering
থাকো
is
থাকো
analogous to the concept of an artist's impression of a scene. We know artists actually perform some art, and there is not always every art have some impressions. But if the artist uh, uh, outlines the impression in his or her art, then the art is actually different from all the other arts. Rendering is actually that kind of thing, but actually define the impression of an image or a video file. We also very much well known about the video editing term. In our day-to-day life, sometimes we need to edit our videos for finalizing the video output. And when we want to edit an video, we must have some effects or some edit type works, and after that we need to finalize that. And when we are going to finalize that, that effects what we have already done on that video, that have to be calculated in certain time, and actually it took some times to finalize the video, and that term actually called rendering. And after rendering, we have found the final video output, what actually called the render. Then here some features of rendering. Here we have seen so many features: shading, refraction, and as our time is short, so we are not going to describe everything. For We are describing some key features. What's actually important? We are going to describe shading, uh, texture mapping, and also non-photorealistic rendering. First of all, we are going to discuss about shading. Shading is the process in rendering that consists of computing the color of objects in the 3D scene. In rendering, we are interested reproducing the shapes, the visibility, and the appearance of object as seen from a given viewpoint. In texture mapping is originally technique was pioneered by Edwin Catmull in 1974. Texture mapping is actually a method for defining high frequency detail, surface texture, or color information on a computer generated graphic or 3D model. When we go for the non-photorealistic rendering, which is also known as NPR, this is actually a area of computer graphics that focused in enabling a wide variety of expressive styles for digital art, in contrast of traditional computer graphics which focuses on photorealism. NPR is also inspired by other artistic modes such as painting, drawing, technical illustration, and animated cartoons. NPR has appeared in movies, video games in the form of cel-shaded animation, as well as scientific visualization, architectural illustration, and experimental animation. These are the key features. We also have some features named bump mapping, fogging, participating medium, shadows, soft shadows, reflection, motion blur, depth of field, caustics, indirect illumination, translucency, diffraction, and refraction. Here we have some example. Here we are seeing a kettle actually. Uh, in the right hand side, we have seen a kettle which is actually a 3D shape, or we can call it as a 2D shape. We are seeing the boxes or the squares are too much big, and when we apply the viewpoint texture lightening or geometry part, and after that we have found the left hand side's kettle is actually much more clear than the right one. Here are also some examples of rendering, and that's all from me. My next member will continue the rest.
Hello everyone, my name is Mohammad Farhan Sadiq and my ID is 171158960. So the presentation topic of mine is ray tracing. So what is ray tracing? Ray tracing is a rendering technique. So what is the specialty of this ray tracing rendering technique? We all know in computer graphics there is 2D and 3D. So in if we want to create a 3D shape, we have to create a lot of polygons to make a 3D shape like circle and other sphere and other things. So what we have to do, we have to render this 3D shape and generate it into a 2D image plan. In our monitor, it is a 2D image plan. So we have to do this rendering thing. In 3D computer graphics, ray tracing is a rendering technique for generating an image by tracing the path of light as pixels in an image plane and simulating the effects of it encounters the virtual object. So the specialty of it increases the realism of a picture. The technique is capable of producing high degree of visual realism, and it makes the ray tracing with the path of the light and create shadows, refraction, and reflections. So why and where do we need this type of ray tracing rendering technique? These rendering technique usually uses real-time applications like video games and other kind of software which is generated 3D rendering is used this ray tracing technique. Here is a picture. You can see the shadows of the light and the shadows of the objects are very clear, and the behavior of the light is too much clear in this picture. So if we want to use it in a video game or an animated movie, so how we can use that? Here is the difference where the ray tracing is off and where the ray tracing is on. If you focus in this part, you can see it is a very matte color in the window. And if you see the when the ray tracing is on, you can see the behavior of light like reflection and refraction and other things. We can see clearly the reflection of this car, this building, and these signboards here in the graphics. Here a popular game called Minecraft, this is in this the right part, this is ray tracing off, and in the left part it is the ray tracing off on. And you can see the visuality of these two part. The here the fire is kind of 2D polygons, like you see different types of shading, and there's a lot of rectangles here. And if you see these picture, you can see we generally change the shapes and change the behavior of the light to make it more realistic. So here is a RTX on, or the ray tracing on technique. You see the shadows and of the light and the environment is changed a lot. A popular animated movie named Baymax, a few years back, it uses the ray tracing technique and generated these rendering techniques by using a supercomputer which is built with 55,000 uh, core, which actually renders a real life scenario for this animated movie. And if we see the advantages of this ray tracing technique is the ray tracing technique actually create attractive environment with shadows and reflections and refractions, and it makes more realistic and increase the realism through the ability of handling inter-object reflection. But there is a drawback. The huge drawback of this is the cost of computing ray object is very high, and the processors and other things we needed to do this ray tracing is way more expensive than usuals. So ray tracing actually create a realistic view, but it creates a lot of it increases the lot of uh, computational expenses. So that was all from me. Thank you, everyone.